All right. The question was, what about this homework assignment every week? That is the first week course syllabus agreement page or acknowledgement page, whatever you want to call that, last page of the syllabus. Either the first or second week you could have done your research paper topic. That would have been fine. And then every week since then, and if you're behind a week or two, go back and do at least one homework problem each week. Just send it to me. You can either attach it to an email, attach it to a Blackboard message. You can, if you've got a way to do a PDF, that's fine. Taking a picture with your phone. I did have a student send me something over the weekend that was a HEIC or something like that suffix on it. My computer would not open that. I know that it'll open JPEGs. Okay, so if you can't do anything else, take a JPEG. But some of these other things, I don't know if that student was using a Mac and the IBMs won't read it. I don't know. I just couldn't do it. So I emailed her back, said I acknowledge that I received it. I just can't open it. So don't need to send it again, but just in the future, send me things that I can open. And a good test for that, see if you can open it yourself. And if you can, now if you're using a Mac, that doesn't guarantee I can open it. But if you're using a PC rather than a Mac, the odds are if your package will open it, then mine will too. Okay, so send me, and what I would prefer, if you are having difficulty with some of the problems, send me those. You're not getting graded on it, so there's no right and wrong answer. It's just getting acknowledged that you sent it. That's all it is. 0 points, but on the grade sheet, and I don't have these set up yet, but when I can finally get around to doing that, then it'll show a 0 there, but it'll be posted. If there's nothing posted, that means I didn't get it or I haven't posted it yet. But if it's posted, 0 score, but posted, that means I got it. And then at the end of the term, if you got more posts than you have blanks, and you are on the borderline between an A and B or B or C or something like that, really close, but not enough for it to round up, I will bump you up. Okay? So that's the deal with that. Does that make sense? Does that answer your question? I'll put you asleep, huh? Okay, good. All right. Any other questions, issues, concerns before we get started today? I see that we have 4 students here. Let me make sure that's all that's in the waiting room. Yep, total of 5, because I count as 1. All right, well, if there's no other questions, let's go on and get the slideshow set up for today. We're in section, chapter 8, section 8.5, partial fractions, and I don't remember, it used to be when I bring up the PowerPoint, it would say from the last slide, and I don't see it doing that anymore. Okay, I believe somewhere right in here is where we're picking up to, oh, this is the last slide in the slideshow, so not going to be here much longer. Okay. All right, so let's get it open from the current slide. Okay, can y'all see my PowerPoint? Yay or nay? Somebody? Okay, good deal. Okay, so we were, I guess, sort of in the middle of example 3. I thought we had finished it, but we really haven't. Okay, I think we had gotten this far in example 3. Now, a couple things about this. If there's no other questions, let me go back over a few things. What this section is dealing with, chapter 8 is integration techniques and improper integrals. Section 8.5 is partial fractions. Where we use partial fractions when we have rational expressions. That's a ratio of one polynomial over another polynomial. Okay. Number one thing to look for, make sure the numerator polynomial is degree less than the denominator polynomial. If it's same degree or greater, do division first. Divide the denominator into the numerator. You're going to get a polynomial with a remainder. The remainder goes back over the divisor. Integrate the polynomial just like you have, and then what you have is what they call a proper rational expression. And then you use partial fractions on that. Now, the second thing to note, and the book doesn't do a big deal about this, I think they sort of say it in a word or two and then skip over it. If you have any common factors between the numerator and the denominator, factor those out. Get rid of them, okay? You don't want those in there. They sort of mess up the thing. But then once you've gotten all the common factors out, you got a proper rational expression, then we start the process of partial fractions. First thing to do, factor that denominator. Factor it as far as it will factor. Now, we're considering factoring a little bit more of a generic thing than what it probably was used to. If you had x squared minus 3, back in the old days you say that can't be factored. It can't be factored using integers, but it could be factored using radicals. That would be x plus the square root of 3 times x minus the square root of 3. That's a factorization. So factor as far as you can. And there's somebody's theorem somewhere out there that says every polynomial with, I think it requires integral coefficients. Maybe not even that. Yeah, but I believe it is integral coefficients. Can be factored into linear factors and non-reproducible quadratic factors. Okay. Now, this is all sort of background. That's leading up to where we are now. I knew Kyle wasn't here the last couple classes. I don't know if he had picked this up, from the YouTube videos, but that's where we are. We're on example 3. So let's go back, and I won't do it, but I'll walk you through what they did. Here's example 3, right there. Now, first, numerator, degree 3. Denominator, you have a squared here and a squared there. If you multiply those two together, x squared times x squared is x to the 4th. That is a proper fraction, a proper rational expression. Okay. Now, the question is that denominator fully factored? This term is, that one is not. Okay, you can factor out a common x, and that leaves you x times x minus 1, and this one will not factor. So now we have 3 factors in the denominator, 2 linear factors and 1 irreducible quadratic factors. If that had been, whoa, here comes Houston. Let me get Houston in here. Oh, and by the way, do any of you, I know that Kira does, are any of you in touch with Esther Kajungi at all? I know Kira said she knew her. Are y'all in touch with her? Anybody? Or can you get in touch with her? Anybody? Okay, if someone's trying to talk, it sounds like water going down a waterfall. Okay, I'm guessing that may have been James because your microphone's on. Were you trying to say something, or is your microphone just not working well? Oh, it wasn't you. Okay. Does anyone know Esther? Esther Kajungi. I may be mispronouncing her last name. She came to one class. I think she borrowed somebody's link. She may not realize this, but they have put her in the class. They tried to explain to me what was going on, and it basically breaks down to Banner not recognizing, I don't know, something about the grades that were entered last summer. It picked up most of them, but it didn't get them all. It did not get her passing, or that she had a grade in Cal 2, therefore they wouldn't let her register for Cal 3, even though she had passed Cal 2. Well, she just, because she was afraid she wouldn't be able to get it in later, this is my supposition here, she went on and registered for Cal 2 again, thinking she could do a drop add after registration was over that next week. Well, she tried to do that. It wouldn't let her do a drop add. And I didn't realize all that was happening until she did come to class that day. So when I was sometime or another last week, it may have been toward the end of the week, it seems like it was, I was talking, I can't remember why I had to contact the registrar's office, but I did, and I actually got the registrar on the phone and said, what's the deal here? And I explained her situation. She said, oh yeah, that's happened to so many students, and she got her name, and I think she put her in the course. So if any of you can get in touch with, or do get in touch with her, know Esther, tell her she is now in the course. She is in Cal 3. Now, if she doesn't want to be in Cal 3, she needs to contact the records office and tell her not to take her back out, because it's just been a total mess up all the way around. So will someone be able to contact her and tell her that? I'm hoping some of you know her better than I do. I mean, she was in my class. I know her that way, but not everybody has phone numbers listed in the system. Not everybody has, I guess most of them have emails in the system, but I thought if she got it from one of you, that would be probably a little bit better. Can one of you contact her? I take that's a no. Well, okay. I'll try to get in touch with her, but I hate it when she's missing class. She may not even know she's in the class. Okay, because the registrar just put her in over the weekend or Friday or sometime. All right, now, example 3, here it is. Well, I've just sort of walked through that. Let me also point something out to you. I'll hold up my book so you can see it. Here is example 3 over here. Notice the red writing right beneath example 3. See larsoncalculus.com for interactive or something like that, something of examples of this type or something like that. I can't read backwards on the small screen. Oh, here comes Laurent. So he's in now. All right. Yes, I can. Who is speaking? Yeah. Houston, yeah. Okay. Now, yeah, I knew who you meant. I picked that up last week sometime that he was JP. Okay. Now, has he lost his Wi-Fi? Is that what you're saying? Oh, he's on campus. Okay. I don't know where he's located there, do you? Oh, he is in the dorms. Okay. I would say, I don't know who to contact. Miss Jamie Glass would be who I would contact, but she's on the Bessemer campus, but I bet you she might be able to help. Her number is 929-3407. Or if you can email her, jglass@lawsonstate.edu. Now, she can't do anything about the Wi-Fi in the dorm. Now, I don't know if anyone can. Jim Mankiewicz would be the closest. I I don't have his number readily available. Actually, I do, but it's a personal number. I'm not sure he wants that given out. But I know his email address is jmankowich, MANKOWICH, at lawsonstate.edu. And more than likely, if you call Miss Glass, she will contact Jim if it needs to be something done at the dorms. He might be able to get over there or send somebody over. I don't know. I can't do anything about someone's Wi-Fi. I wish I could, but I would say for him just to keep trying, but contact one of those two people and see if he can do anything to get in. I don't know if it's a problem with Lawson's Wi-Fi. I just don't know. I do know this, and for those of you who weren't around, last week, I believe it was last week, one day Zoom actually crashed. Not everywhere and not totally, but they had a major shutdown. UAB was heavily affected, and certain areas of the country were. And this, for my classes, my first class went through fine. The second class, this class, I think it wouldn't connect for about 30 minutes and finally did. And then the third class connected fine. So they did get most of the problems straightened out, but that doesn't mean it was everywhere. So it could be that, you know, Lawson's Wi-Fi is still having difficulties with Zoom. I don't know. That doesn't make a lot of sense, but this is near the middle of the day when probably they have maximum usage, and it may just get very hard bandwidth. I don't know what would be going on. So I'd say just try one of those people and see if he can get some help getting on. I wish I could had a magic bullet, but I don't. Okay, I don't have any bullets. Okay. All right. Now, any other issues, concerns? Thanks for telling me that, but I just don't know. But I wish there was something I could do. Okay, so we're going to step through this problem fairly quickly just because a few of you weren't here last time. Here's how it goes. Factor that, well, it's not going anywhere, is it? Okay. All right, factor that denominator as x times x minus 1 times x squared plus 4. Linear factor, irreducible quadratic factor. You should always be able to get these done. Now, what we didn't do was check to see if there were any common factors between numerator and denominator. I think in class I kind of did that for you, but take my word for it, there's not. Okay, so what we do, for the denominator, we split into these factors now. That's the same denominator. Oh, here comes your manual. He did get in. All right. I don't know what he did. Something magical, I guess. Okay. Good to have you, Jemanuel. Now, all we're missing is Esther. Perfect attendance, except for Esther. I'm not even sure she's aware she's in the class. So I ask again, I'll plead again. Do any of you ever in contact with Esther? Could you let her know they have now got her finally in the class? If she wants to take it, she needs to get in touch with, she needs to start coming, because they have now let her in, and unfortunately she probably is behind a little bit, but it's all catch-upable. Okay. Okay. So factor that denominator. Now what we have written here is exactly your integral here. It's just that we factored the denominator completely. Now we, what they call, decompose this into partial fractions. This first is a linear factor, so it will have a constant over it, a over x. They just chose capital letters here. It's sort of standard. The second is a linear factor, so they'll do a b over x minus 1. Notice the numerator is always 1 degree less than the denominator. Denominator degree 1, this is degree 0. Denominator is degree 1. This is degree 0. This factor in the denominator is a second degree. It's a polynomial factor, a quadratic factor. So therefore, it will have a linear numerator. And you keep that as general as possible, cx plus d over x squared plus 4. Okay? Now we proceed to, we've decomposed it, but we got to find out what these 4 variables are. So the next step to do that is multiply everything on both sides of the equation. What's messy about this are these denominators. But if you multiply both sides of the equation with by the least common denominator, which is x times x minus 1 times x squared plus 4, this whole denominator goes out here, and you're left with 2x cubed minus 4x minus 8. So that's going to be left over here. When you multiply this term by that, the x's will go out, and you're left with a times x minus 1 times x squared plus 4. Don't worry with multiplying these together yet. Leave them separate. Leave them as factors. When you multiply this term by that least common denominator, the x minus 1's go out, okay, leaving you a b times x squared plus 4. And when you multiply this term by that least common denominator, the x squared plus 4's go out, and you're left with cx plus d times x minus 1. No more denominators, but your numerators did get a little messier. Okay, left-hand side stayed the same, the others got a little messier. So that's what they did, if I could get it to advance, did next. Multiplying by the least common denominator yields this equation. Left-hand side is just your numerator. The right-hand side is a times x minus 1 times x squared plus 4, because that x went out with that one. The bx, they went on and multiplied those two together, because the x minus 1's went out, times x squared plus 4. And then the last term was cx plus d, because the x squared plus 4's went out, times x minus 1. And again, don't worry with multiplying these terms together. Yeah, you can multiply b times x, that's no problem. But don't try to redistribute that. Leave it alone. All right, now, that's an equation. That should be an equation good for any numbers a, b, c, or d. For any variable x, it should be good. Okay? And one variable that it would be good for, if you suppose x equals, let's start with 0. If x equals 0, this becomes minus a times 4, right? When x equals 0, this term becomes a minus 1, that term becomes a 4, that would be minus 4a. Okay? This term completely goes away, because if x equals 0, bx is equal to 0, 0 times this would be 0. This term goes completely away because that factor of 0 in there. So what you wind up with, when x is equal to 0, the left-hand side is minus 4a. The right-hand side, because x is 0, is equal to minus 8. So a is equal to 2. Okay? Now, the next step would then be, let's set x equal 1. Now this term goes away, and this term goes away. So you're only left here, and you have b times 1, which is b, times 1 plus 4 is 5, so that would be 5b is equal to, and when b is 1 here, you get 2 minus 4 is negative 2, minus 8 is minus 10, and what do we have? 5b is equal to negative 10, b is equal to negative 2, and that's what you get. And that's about where we stopped before. Okay, so here's what they did. They got a is equal to 2. When you plug x equals 0, you get minus 4a is equal to minus 8. So a is equal to 2. Solve for b, let x equal 1. You get minus 10 on the left, 5b on the right. So b is equal to minus 2. That's where we left off last time. All right. That's all the easy part. Okay. Now we do what's left. Okay. And here's what's left. This point C and D are yet to be determined. You can find those remaining constants by choosing two other values for x and solving the resulting system of linear equations. Okay, that's one way you could do it. Okay, now they chose for x equal -1. Now, of course, you already know your a is 2 and your b is -2, so plug those in as well. Oh, hey, here comes Esther. Good deal. Perfect, perfect, perfect attendance today. Way to go, team. Okay, we got everybody here. I think this is the first day we've had this since the very first day of class, but then Esther wasn't in the class. Now we've got everyone here. That's so good to see. Okay, you know how to make my day. Everybody show up. And by the way, this morning in my first class, everybody was there too. So it's been a perfect Monday so far. Keep it up, folks. All right, so there you're going to use x equal -1. Now this is one way you could do it. It's not the only way. So what we'll do with that, and I think what I'll do is go back and write down what we had, because that's a couple slides ago. So let me write down where we left off. Okay, we had 2x cubed minus 4x minus 8 is equal to, now we know a is equal to 2, okay, and they're going to let x equal, well, I'll just write it down. I'm going to write down everything. 2 times x minus 1 times x squared plus 4 plus b, which is a, oh, what happened there? Did someone come in or go out? No, I guess everybody's stable. Okay, looks like they are. All right. Where were we? Minus b is -2, so that would be a minus 2x times x squared plus 4 plus cx plus d. That's supposed to be a capital D. I don't know why I wrote that. Times x minus, -1. Okay, there's our problem. Now, I can't erase on this screen, or I'd fix that D and make it look better. So they say let x equal -1. Why not? It's a pretty simple number. This will then become -2, because -1 cubed is -1 times 2 would be a -2. This would then become a +4, because -4 times a -1 would be +4, -8. So the left hand side becomes that. On the right hand side, you got 2 times a -2, because -1 is -2, times a -1 squared is 1, plus 4 is 5, minus, plus, okay, because a -1 here times that would be a +2 times, and -1 squared would be 1, that's a 5 again, okay, plus, well, actually minus, because of that x there, and this would then be cx plus d times a -2, wouldn't it? Yeah. So that now becomes +2. All right. The -1 here, -2 there, becomes a +2 times cx plus d. All right, let's see what that gives us total. This is -10 plus 4 is -6 is equal to, and this is a -20, correct me when I make my mistakes, plus 10 plus 2cx plus 2d. Agreed? Okay, these two together add to be a minus 10. So if you add 10 to both sides, that gives you 4 is equal to, oh wait, there's no x in there. X was a minus 1. Sorry about this. That becomes a minus 2c, and that becomes a plus 2d. Sorry about that. All right, where was I? Okay, that would be a minus 2c plus 2d. Well, I'm going to simplify that and rewrite that as, I'm going to do several things to it. I'll leave it. Minus c plus d is equal to 2. All right. Now, let's take x equals some other number. Now remember what we've used already? We used the 0, took care of that. We used the 1, we took care of that. Now we use the minus 1. What other x would you like to use? I would suggest maybe 2. So let's go to our original equation here and plug in a 2. That would be 2 cubed is 8 times 2 is 16 minus 8 minus 8. That's interesting. Over here we have 2 times 1 is 2 times 2 squared is 4 plus 4 is 8 minus 2 times 2 is 4, and this again was 8, so 4 times 8 is 32, I think. Okay, plus, this time we'll plug in a 2 here. This is 2c plus d times 2 times 1 is 2. So I'll put the 2 out front. All right, let's combine here and we get a 0. We get nothing. This gives us a 16 minus 32 plus 4c plus 2d. Everybody follow what I'm doing? So this is going to be, if I can get my this to show up, there it is. Yes. Okay. Okay, up here in this step right here. Is that what you mean? Okay. All right. Now, yeah. 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 If you see this, minus 2 and minus 8 is minus 10 plus 4 is minus 6. Right? And this one gives you 2 times 5 is 10 times minus 2 is negative 20. This is just a plus 10. This one, I forgot to write it down, but x was a minus 1, so this became a minus c times a plus 2. That would be a minus 2c, and this will just be plus 2d. Okay, and then I combined those together. This gave you a minus 10 here. Add that to both sides, a 10 to both sides. That gives me a 4 is equal to minus 2c plus 2d. Just divide everything by 2 and get minus c plus d is equal to 2. I'll just change sides. Down here we're going to do something very similar. Combine these two and you get negative 16. Add that to both sides, you get a 16 is equal to 4c plus 2d. And then I'll do the same thing I did before. Divide by 2, and that would give me 2c plus d is equal to 8. Right? Alright. So I'm going to put these two together. This one and this one. Two equations, two unknowns. 2c plus d is equal to 8, and minus C plus D is equal to 2. Now I'm going to notice here the D's are the same, so I'm going to subtract this one from that one. So it's a 2C minus a minus C would be 3C, because these subtract to 0 is equal to 6, so C is equal to 2. I hope that's right. Well, yeah, C is equal to 2. That's what they got. All right, now we know everything except D, and it looks like the simplest equation would be this one right here. Just take this and say D is equal to 2 plus C. C is 2, and D is equal to 2 plus 2 is 4. Didn't know you'd be doing such high-level math today, did you? 2 plus 2 is 4, and that's what they got. All right, all that to give you your 4 constants. A is equal to 2, B is equal to minus 2, C is equal to 2, and D is equal to 4. All right, where do we go from here? Go back to our original situation. So I'm going to actually go back a slide, 2 slide, 3 slide, 4 slide here, and rewrite this thing here. A, remind me, was that 2? I believe it was. Be 2 over x minus 2 over x minus 1 plus, I believe that was the 2 also. Well, yeah, 2x plus 4 over x squared plus 4. That's what I'm going to write in my integral. And guess what? That at least is somewhat easy to integrate. Okay? Now, they show how they do it, and I wish I could erase my writing. I can't, so just pretend the red's not there. This is what we got, remember, right down here. Minus 6 is equal to minus 20 plus 10 minus 2c plus 2d. Yeah, that's exactly what we got, and that yields 2 is equal to minus c plus d. That's exactly what we got here, and stop right there. For x equal 2, they chose the same thing we did. We have 0 on the left hand side, which is exactly what we got, equal to 16 on the next term, minus 32 on that term, and then this one gave us a plus 4c plus 2d. That gave us that, and they just skip a bunch of steps and say 8 right here is equal to 2d plus 2c plus d, exactly like I got there. I think someone had to leave the room. I don't know who it was. Hopefully they'll be back. Okay, now what they do from here, 2 equations here, one there, 2 unknowns. You call it elimination by addition. You did this back in algebra somewhere. Okay, solving the linear system by subtracting the first equation from the second. That's what we did. This becomes 3c is equal to 6, c is equal to 2. Then you can plug that back in here and say minus 2 plus d is equal to 2, add 2 to both sides, d is equal to 4. Okay, now we take that original complicated looking rational expression and write it into the integral of simpler ones. 2 over x minus 2, this is the a, 2 over x, minus b was minus 2, minus 2 over x minus 1, and then d was a plus 2, so plus 2x over x squared plus 4, and then your last one was d was equal to 4 over x squared plus 4. Now, split these into 4 different integrals. In other words, we integrate this dx, integrate this times dx, integrate that times dx, and integrate this times dx. Oh, you can just use that dx there. Okay? Now, this is 2 times the log of absolute value x. You have to put absolute values in there if we don't know anything about the system. And they didn't tell us anything about it, so we have to. Now, if they said the x's here were all between 10 and 15, yeah, we'd be fine. We wouldn't need an absolute value x. But we don't know that. X could be negative, so we put absolute value. This next one is, again, plus 2 times the natural log of absolute value x minus 1. That next one, okay, now here looks like a good place for a u substitution. Let u equal x squared plus 4, okay, that denominator. Then du is equal to 2x dx. Hey, how nice. There's your 2x dx there, and here's your u squared plus 4 there. I mean u plus 4 there. So what does that give you? That gives you the, no, I mean just u. So what you have now is the integral of du over u, which is natural log of absolute value u, which, because u is this is natural log of, guess what? Don't need absolute values anymore because x squared will never be negative and 4 is not negative, so this would just be x squared plus 4. Okay, so that's the next part. Plus natural log of x squared plus 4. And then this last one, yeah, boo hiss. That's a trig substitution. And that looks to me like a tangent substitution. Let x equal 2 tangent theta. Okay, so x squared would equal to 4 tangent squared theta. And then you add 4 to that, and that gives you 4 times tangent squared theta plus 1, and this would be 4 times secant squared theta. Okay, that's going that way. Let's do our dx would be 2 times what's the derivative of tangent? Secant squared d theta. Okay, so this last integral becomes the integral of, I believe it's 4 times the integral of, let's take that 4 on the outside, and your denominator is 1 over 4, so take that on the outside. That gives you a 1 there. Okay, your numerator is just your dx then, if you took the 4 on the outside. Dx, but dx was 2, let's take the 2 on the outside too, secant squared theta d theta, and your denominator is simply, we already pulled the 4 on the outside, that's just secant squared theta. Those disappear, and you just have theta, 2 theta. Well, what's theta? Theta was, from right here, x over 2 is equal tangent of theta. So theta is the inverse tangent of x over 2. So this last term here is plus it was a 2 theta, so it would be 2 times the inverse tangent of x over 2. I think I did that right. Whew. And then, don't forget your plus c because this is an indefinite integral. All right, let's see how they did it. There's our answer. 2 times log absolute value x minus 2 times log absolute value x minus 1 plus log times log of x squared plus 4 plus 2 times the inverse tangent of x minus 2, x over 2 plus c. Okay, yeah. And they just wrote the answer down without explaining how they got it. Okay, any questions on that? I know that was a lot of hocus pocus and here you there, do that, this, that, and the other. Did you follow that? Are there any questions about any of those steps? Anybody? Good exercise in integration of a variety of things, your U substitution and also trig substitution. Okay. Now, here are some guidelines for solving, and by the way, let's see, before we do that, there's example 4 before the guidelines. So let's go and do example 4. So let me back up a slide, and I'm going to write this one on the whiteboard. Okay, now I've got more housekeeping to do. Got to move this taskbar that you probably can't see up here as far as I can over there. I want to move Jesus, he's in the way again, as far to the right as I can, all of us actually. And then the whiteboard here, I'm going to move up as far to the up and left as I can. You probably don't see anything but white. I've got a limited area I can write in, so there's that. Okay, let's do example 4. Okay, somewhere here, oh, if I get the right end of my pen, that may work. Okay, what in the world are you doing? Why did screen sharing pause? This is so nuts. Okay, we're back again. All right, here's example 4. Find the integral of 8x cubed plus 13x okay, that's in the numerator. The denominator is x squared plus 2 squared, and that's times dx. All right, I think I've got that written correctly. Now we proceed. Now, the only time we worry about factoring the numerator is if we think there may be a common factor between it and the denominator. So you could factor out an x there, but guess what? That leaves you 8x squared plus 13. X squared plus 2 is never going to go into that an even number of times. So no, there aren't any common factors. Okay. Now, number 2, look at the degree of both the numerator and the denominator. Degree of the numerator is 3. Degree of the denominator is, yuck, I didn't do that. I didn't even get close to the page and it decided to write. Okay. This is ugly. Okay. So let me get this. That was a x squared plus 2. Okay. The pen does strange things sometimes. It'll be nice and smooth and then suddenly you get jerky. Suddenly it'll send a line, horizontal line or a vertical line somewhere in the page. I don't know why it does that. I think there's a sensitivity issue I don't know how to resolve. but hopefully one day I may figure that out. But what I was going to say, look at your what I'll do, I'll be safe. I'll use my finger on the keypad. This is x squared squared, so that's going to give you at most an x to the fourth. Ha! Numerator is degree 3, denominator degree 4. We have an improper fraction. Okay. Now, what we're going to do is take that integrand out of there, and later we'll put it back. So let's take it out, and it'll be 8x cubed plus 13x. I have to write real slowly to keep it from jerking around like it did on the 3 there. Okay. Divided by, now let's factor that denominator. It's going to be oh, it took out my square here. Okay. X squared plus 2 times x squared plus 2. Sometimes it writes and sometimes it doesn't. Okay. Now, using the concept we had before, okay, this is going to be, see, took out my plus sign. Okay. These are not reducible. Okay. Now, so you're going to have an ax plus b, because this is a quadratic down here, it needs to be a linear up here, ax plus b over x squared plus 2 plus, okay, we got another one. If we just did a dx plus a cx plus d over x squared plus 2, that'd be basically the same thing. So this time we have to do a d, or it doesn't matter. I can erase that one, so I'll erase. Oops. Okay. Cx plus d, doesn't matter what you name them, over x squared plus 2 squared. You see, anytime you have a repeated root like this one is, you do it the first time over the first power, second time over the second power, but you still just do, since those are quadratic factors, you just do linear. You don't need a cubic up there. That's fine. There is what we've got. And guess what, team? There is no simple, well, let's let x equal something to eliminate. Not going to happen. So we've got a little bit more work on our hands. But the first deal is to multiply by the least common denominator, which is either written like this or written like that. So we're going to multiply this by x squared plus 2 times x squared plus 2. I just have to write slowly. Okay, multiply this one by, I'm going to shorten this one, x squared plus 2 squared. And multiply this one by x squared plus 2 squared. Okay. These two go away. One of these goes away. Both of those go away. So what do we have left? I'll start over here. 8x cubed plus 13x times, that's all. I didn't need those parentheses. Sorry about that. Is equal to, I do need them here, ax plus b times x squared plus 2 x squared plus 2, because one of them went away, plus, and this will just be cx plus d. Alright. Now, again, nothing's going to be particularly easy here. And what they suggest is just picking numbers. So my favorite number, one of them, is 0. X equals 0. Left hand side becomes 0. Right hand side becomes, that goes to 0. You got a b times 2. So that's 2b. Okay? And this will be plus d. That made things a lot easier, didn't it? So there's one equation. Let's pick an x equal 1. So this will be 8 plus 13 would be 21 is equal to x equal 1 here. You'd have a plus b times 1 plus 2 is 3. So that would be 3 times a plus b. Everybody with me so far? Alright. And then the last, yes, question.
You put 21 and that will go in for all the x's? Or?
Okay. What I did here, okay. This one right here, I put let, I didn't write it because my writing is so, let x equal 0. And that's how I got this one, right? This one I said let x equal 1 up here. Okay, so in x equal 1, x cubed is 1, x is 1, so it's 8 plus 13 is 21. X equal 1 here would just be a plus b. X equal 1 here would be 1 plus 2 is 3. 3 times a plus b. Plus, x equal 1 here would be c plus d. Alright, so I'll rewrite this ever so slightly to be 3a plus 3b plus c plus d is equal to 21. This one I'll rewrite to be 2b plus d is equal to 0. Alright. Now we do the same thing for another number. They usually like to use -1, so let's do that. Let x equal -1. Okay, let's see what we get. This will be a -8 and a -13, so that'll be a -21 is equal to, this will be a -a plus b times 3 again, because -1 squared is still 1 plus 2 is 3. Okay, that's a minus down there. It wrote rather bizarrely. And this would be a -c plus d. So this would become -3a -3b -c plus d. No, I did that wrong. That's a plus 3b minus c plus d. And that's equal to -21. Right over here. Alright, next number, why not 2? Let x equal 2. So what we get there, 2 cubed is 8 times 8 is 64 plus 26, ooh, big numbers. 64 plus 26, 90? Is that right? Somebody with a younger mind than me should figure that out. Okay. The right hand side would be a 2a plus b. So let's write that down. 2a plus b times, if you put a 2 in here, that would be 2 squared is 4, plus 2 is 6. Okay. Plus 2c plus d. Alright, and that would produce 12a plus 6b plus 2c plus d is equal to 90. Alright, I'm going to have to take a quick time out here. My throat's getting incredibly dry, so hold on. Okay, feels a little bit better. Okay, now we have 4 equations with 4 unknowns. Alright, now that first equation up here, we could do this to this. D is equal to a minus 2b. This is one messy problem. And the way I was wanting to do it myself, I thought they were going to substitute numbers in, so I did, and it comes out really messy. What I was going to do was just work it out, but I refrained from doing that because of what they did on the previous problem. I wish I had just worked it out. So what I'm going to do, sorry about this folks, this will work, but it's going to be long and tedious. Here's what I was tempted to do, but I thought it would be worse. It's not. Okay, I'm going to go back to the very first step here, and I can even drop my parentheses there, which I don't need. The others I do. Okay, I should have followed my inclination, but they had done it the other way, so I was going to do it the way the book did, and now the book turned around and did it the way I meant to do it. Okay, so sorry about this. That way works. It's a perfectly fine way, but you have a system of equations. For those of you who have linear algebra, that's not an impossible system to do. In fact, it is a little messy, but it still is doable. This way I think works better. And like I said, it's the way I was about to do it, but I thought, no, that's not how the book does, so I didn't look at the book. I just assumed they did it the same way the last one. Okay, here's what we're going to do here. Okay, write this down. 8x cubed plus 13x is equal to, we're going to FOIL this one. This will be ax cubed. That's what you get from FOILing this and that, right? Then going to FOIL this, and that would be plus bx squared. Okay, and then the x term will be plus 2ax, that's for this one with that one, plus 2ax, and then the last term is just going to be plus 2b, or not 2b. Okay, and then we have a plus cx plus d. I wish I'd have done this the first time. Okay, now just looking at this equation here, we see right off the top that a has to equal 8, because that's the only cube term you have on either side. So here we have a is equal to 8. Already got one of our coefficients down. Now we also see that b here has to equal 0, because there is no squared term here and here, so b is equal to 0. Boy, this is so much easier than the other way. Okay? Now your x terms. Over here you have 2a plus c, so 2a plus c is equal to 13. Okay? And then your constant terms are right here. 2b plus d has to equal 0. 2b plus d is equal to 0. Now, we know what a and b are. So let's simplify things here. A is 8, so the first one there is 16, plus c is equal to 13. So guess what? C is equal to -3, right? And we know what b is, it's 0, so guess what? D is equal to 0. If b is 0, then d is equal to 0. So this really simplifies. Here is our new integral. Rather than this thing, we're going to put this thing. Not with all the mess in there, but with originally what we had. The a is 8, the b is 0. So this would be 8x over x squared plus 2. That's this one. Dx plus the integral. C was -3, so I think I'm going to change this to be a minus. I think I'll pull my 3 on the outside too. I would have done that to the 8, but there's a reason I'm not going to yet. -3, and that would be an x over, now let's see here. Yeah, we'll write it as x squared plus 2 squared, and that's times dx. Now, here a u substitution will be worked very nicely. Let u equal x squared plus 2. Then du is equal to 2x dx. Goodness gracious. But we have an 8x dx. So let's take a 4 out here and leave us a 2 in there. 2 times that. Okay, that will work. Okay. And then what we have is 4 times the integral of du over u. We can do that one. All right. -3. Now let's do this one. This would be, in this case, a different u substitution. Let u, in fact this is the same one, equal x squared plus 2, and du is equal to 2x dx, just like before, but here we only have one x. So to make this let's divide both sides here by 2, So that would be minus 3 over 2, because we're going to have a 2 in your denominator there, times the integral of, and this would be u to the minus 2, because remember our u was x squared plus 2, in the denominator squared, so that u to the minus 2 du, because the du was x dx when I divided out the 2 here. Okay, well, what's this one? I wish I had more room. Okay, going back to here, this is going to be 4 times the log of u, absolute value of u. Well, what is u? X squared plus 2. Well, I don't need the absolute value. That's just x squared plus 2. Now, was that someone trying to get back in? I don't think so. No. We lost somebody somewhere, but I don't know where that is. Okay, why did you do that? Okay, now we're back. All right, so that's what we got from here. From here, we got a minus 3 halves. Now, what's the antiderivative of u to the minus 2? Well, add 1 to that, you get a minus 1. Divide by minus 1, so that's going to be a plus u to the minus 1, but u is x squared minus plus 2, so it's 2 times x squared plus 2. Now I know I've left off some steps here just because I was running out of room, and then finally we have a plus c at the end. So I think that's what we get as our answer. 4 times the log of x squared plus 2 plus 3 halves, or 3 over 2 times x squared plus 2 plus c. Yes. Any questions on that one? Y'all are being amazingly silent. Any questions?
When you start doing the whole new thing.
Okay, say that again.
I got lost when you start doing that. When you erase the other one, you got this.
Oh, okay.
I erased it, but I don't get this.
Okay. All right. Well, you see what I did? I just wrote this one down, right? Just write it down.
Yes, sir.
Do you see that I'm multiplying this? Foiling it. Okay, so you got this part. I'm sorry, you're fading out. You see it?
You put the cubes together.
When what? Oh, yeah. Okay, so you agree with this. 8x cubed plus 13x is equal to ax cubed plus bx squared plus 2ax plus 2b plus 6cx plus d. You agree with that step, right? This line right here. You got it. That one's okay. Now, we start comparing the left-hand side to the right-hand side. There's one cubic term here, and there's one cubic term here. For these two things to be equal, they got to be the same. So a's got to equal 8. So do you buy that one? Yes?
Yeah, I got that one.
Okay. Then the same thing here. We look at the squared terms here, bx squared. Here, there aren't any square terms. So that tells me that b has to be 0. Do you buy that one? Okay. Now we look at the x terms here. Here we're going to have a 13. Over here we have two terms with x in them. 2ax plus cx. So that would be 2a plus c times x. If you factored out the x, be 2a, capital A, plus c, yuck, times x. If you put these two terms together, this is what you would get, right? So the x coefficient on this side is a 13. The x coefficient here is 2a plus c. So that's how we got this one. 2a plus c is equal to 13. Those are the coefficients for your x's, here and here. And then for the last one, your constants, you have a 2b plus d over here, and you have nothing over here. So 2b plus d has to equal 0. Okay? All right. Now, from this point, we can plug in our a's and our b's here, and the a is 8, so 2 times 8 is 16, plus c is equal to 13. And that's how we got this equation. And that gives me c equal negative 3. And in this one, 2b plus d is equal to 0. We put b equals 0. That gives us d is equal to 0. I'll buy that. So now I plug those back into this original form, putting those in the integral, and I started off with the 8x, that's the a, 8x plus b, and b is 0, so just 8x over x squared plus 2. So that's what I started with here. Later I factored out a 4 and made it 2x here, because when we did our u substitution, all I needed was a 2x in there. So I wanted the 4 on the outside, 2x on the inside, and now that's du over u, which is what we got here. Over on this one, we had the c was a minus 3, so I put the minus 3 here, and just put the x up here, over x squared plus 2 squared, because this was our second term here. The d was 0, so put this here. All right. Now, again, do the same u substitution here, but this time the 2x dx, you don't have a 2 up here, so divide by 2, and that put a 2 underneath this one. So that's where the 3/2 came from. Here, this was 4 times the integral of du over u minus 3/2 times the integral of u to the minus 2. This was your u in the denominator minus 2 du. Your du was, or 1/2 du, was x dx. So that's just this u substitution there. So here are your two, yuck, u substituted. Let me see if I can erase those. For some reason, sometimes you just get close to the board and it just starts writing. Other times I'm on the board and it won't write. I can't figure it out. Okay, so this is 4 times log u, right? Okay, minus 3/2 times, this will be u to the minus 1 divided by minus 1, so make that a plus 1. So that'll be u to the minus 1 du. Well, u is x squared plus 2, so 1 over x squared plus 2. That's where that came from. The 3/2, the minus, that became a plus, 3/2. So here's 4 log, and here again the x was the same, x squared plus 2. U was, log u would be 4 log x squared plus 2 plus 3 over 2 x squared plus 2 plus c. Alright, I know that was sort of fast and it's all over the whiteboard, but I just have limited room to write. So were you able to get it?
Yeah, I just have to go over it again. But
Right. Alright, good deal. Any other questions? Great question, by the way. Alright. That then was example 4. And we got exactly what the book did. They have a little technology blurb at the bottom, and you can certainly do that, see it. And you see that the two equations graph right on top of each other. Why, I'm not really sure. They do that. But anyway, now, getting back to the slideshow. So let's go back to our new slide again, going back to 8.5. That's where we were. All right, and we'll go from current slide. Why is this doing this stupid stuff? Okay, let's try it again from current slide. There we go. All right, this was example 3. We did example 4. Here are the guidelines. Now, before they got to this, at the top of page 556, which they don't put on the slide set, it said, when integrating rational expressions, keep in mind that for improper rational expressions, and they give one, it says you have to do your division first. So let's go back and do that. I thought they were going to show it on the slide set. They didn't. So let's go back to the screen whiteboard and do that. All right, clear that out of the way. Anyone need that any longer? Okay, it's going, gone. Okay. What if this was your integrand? Two x cubed plus x squared minus 7x plus 7 divided by x squared plus x minus 2. Okay. Now, a couple of things. I guess first and foremost, obviously the numerator is higher degree than your denominator. So therefore, this is not eligible for partial fractions yet. You have to do the division. Now, this you can't use synthetic division because you don't have it in the form of x plus or minus a or b or whatever. Okay, so we're going to do a division here. I'm going to divide the denominator into the numerator. 2x cubed plus x squared minus 7x plus 7. I hope I copied it right. All right, now, first and foremost, when you do division of polynomials, be sure you have no skipped terms either in the numerator or denominator. We don't. Look at your exponent. 2, 1, 0. That's fine. 3, 2, 1, 0. That's fine. So if you had any skipped terms, you have to put a 0. Like if this had been a 2x to the 4th plus x squared, you'd have to put a 0x cubed in there just to hold the place. Okay. But we have them all, so we're okay. So now from here, we do our division. X squared into 2x cubed will go 2x times. Okay. Okay. Now, multiply. 2x times x squared is 2x cubed. 2x times x is plus 2x squared. 2x times minus 2 is minus 4x. See, this way you keep like terms on top of each other. Okay? Now, we subtract. But since you have signed numbers, I like to change signs and add. So I'll make that a minus, make this a minus. That is a 2 there. It just didn't show up. Make that a minus and make that a plus. Now add. These add to 0. This adds to minus x squared, and this adds to plus 3x. Bring down to 7. Okay? Now, divide again. X squared into minus x squared will go minus 1 times. Multiply minus x squared minus x plus 2. Okay, this time we're going to subtract again, which I'm going to change signs and add. Plus, plus, and make this a minus. And this adds to 0. This is 4x. And this is plus 5. Okay, so what is our answer here? 2x minus 1 plus 4x plus 5 over your original denominator, x squared plus x minus 2. Okay. Now, since this was originally what you probably would have been integrating, you now integrate this. Well, that's a piece of cake. You integrate 2x minus 1 dx. Then you do plus the integral of 4x plus 5 over x squared plus x minus 2 dx. Okay, I can do this one. It's just x squared minus x, right? Plus. All right, now we do the partial fraction on this part. Well, that denominator factors to be x times x plus times minus. I think it will be a plus 2 and a minus 1. Okay, so that will then be 4x plus 5. Yuck! Get out of there. 4x plus 5 over x plus 2 times x minus 1. No. Yeah. Okay. Is equal to a over x plus 2 plus b over x minus 1. Now remember, this factor is a linear factor, so you put a constant over it. That factor is a linear factor, so you put a constant over it. Multiply both equations by x plus 2, that's ugly, times x minus 1. Multiply this by x plus 2 times x minus 1. Multiply this by x plus 2 times x minus 1. Okay, here everything goes away. So you get 4x plus 5 is equal to, here the x plus 2's go out, and that gives you a times x minus 1 plus, here the x minus 1's go away, and you get b times x plus 2. Whew. All right, now your tricky step, let x equal 1. That way you'll wipe out this term here. Okay, so you get 4 plus 5 is 9. When x equal 1, that'll be 9, is equal to, x equal 1 here will be 3, 3b, so that implies that b is equal to 3. Then let x equal -2. Now what you have is -8 plus 5 is -3 is equal to, and here this will be -3a, and this will be, that will go to 0. So a is equal to 1. Alright, now the integral would be, remember this part was there, this integral will be plus the integral of 1 over x plus 2. From up here, a was 1, plus 3. I'm going to put it on the outside. The integral, and this is a dx. I knew I was missing something. Whew, goodness, I'm about out of juice here. B was minus 3. B was plus 3. I already pulled that out. So this is a dx. Goodness, where is my pen? It was right there. There it is. Okay. Dx over x minus 1. Okay. So what you get here, this is simply the log of absolute value x minus 2 plus 3 times the log of x minus 1. That's it. Okay, they didn't work it out, but we, oh wait, I bet, yuck, I'm glad they didn't, because I messed something up. I got a remainder of, oh, I forgot to subtract. No, I did subtract. They got minus 2 plus 5, I got plus, oh, I messed up. That was a minus 3. And then you subtracted, okay, sorry about that. So this is a minus 2. So ignore the rest of it. That was a minus 3 plus 2x plus 5. Sorry, I should have stopped and looked at the book. Well, I can't get my pen. Minus 2x. Okay, but anyway, they didn't do the problem, so don't sweat it. Okay. Whew. We got 3 minutes. Let's see what we can do in 3 minutes. Let's go back to the guidelines. Okay. Goodness gracious. It's getting awfully hot in this room too. I don't know if that's part of the problem or it's just I'm wacko today. Okay, let's go from current slide. Well, I thought I went from current slide. Okay, here they are. Here are some guidelines for solving basic equations that I obtained in partial fraction decomposition. Linear factors. Okay, substitute the roots of linear factors into the basic equation. Oh yeah, what he means is once you have it done out there, if x minus 2 is a factor, the root would be x equal 2. Put that in, it simplifies things big time. For repeated linear factors, use the coefficients determined in the first guideline to rewrite the basic equation. Okay? Then substitute other convenient values for x and solve for the remaining coefficients. We kind of did that. For quadratic factors, expand the basic equation. That's what we did. Collect terms according to the powers for x. That's what we did that second time. That works better there. Equate the coefficients of like powers to obtain a system of linear equations involving a, b, c, and so on. Then solve the linear system of linear equations. Okay, so basically if you have linear factors, pick the root, let that equal the x value. That simplifies the whole process. If you have quadratic factors, then collect powers of x like we did. Now what they didn't mention, you always start with making sure there's no common factors, and if the degree of the numerator is greater than the degree of the denominator, do your division first. Okay. Let's see if they have this next slide. No, they don't. At the very bottom of the page it says, before concluding the section, here are a few things you should remember. First, it is not necessary to use partial fraction techniques on all rational functions. For instance, the following is more easily found in the log rule. If you can use a U substitution to simplify it, don't mess with partial fractions. It's just not necessary. Okay? Secondly, when the integrand is not in reduced form, reducing it may eliminate the need for partial fractions, because if you have any, this is what I've been saying all along, any common factors, get rid of them to begin with, and then you won't need probably to do partial fractions after all, or it may reduce the need for it. Finally, partial fractions can be used in with some quotients involving transcendental functions, like with sines and cosines, if you can do a nice U substitution for that and then proceed with that. All right, that finishes 8.5. Any questions on 8.5? Homework questions, exercises here, any of the odds, 3 through 19. They're all at Calc Chat, 7's at Calc View. Either 21 or 23, both at Calc Chat, 21's at Calc View. 25 through 31, all at Calc Chat. 33 or 35, both at Calc Chat. You can explore doing 37 or 39. They should both be at Calc Chat. You can do either 41 or 43. They should both be at Calc Chat. 45 and or 40, well, let's see, any of the odds 45 through, I'd say 51. They should all be at Calc Chat. All right, that's on pages 557 and 558. Okay, next time we will do 8.6, which is numerical integration. Hopefully we will get the entire section done. It's a fairly short section. If we get it done, we're probably going to skip, well, I will mention 8.7 because that's how you're really going to do a lot of integration problems. You're going to use tables. But I think y'all are used to using tables, so rather than going through all those, we just don't have a lot of time. We'll go through how to use a table and then skip that. I won't assign any homework in it. Then 8.8 is improper integrals. They don't include that yet. They pick it up sometime later. We may not have time to come back and pick it up, so don't sweat that. We may just do that as a slideshow. In fact, both of those last two sections I'll probably just do as a slideshow, not giving you any homework exercises, but just showing you the slides. I know I put them on the PowerPoints out there for week 3, so they're there if you want to look at them. And if we finish all that next time, we may get started in 9.1. Okay, if not, we'll begin that next week. Oh, and when we do finish 8.6, which probably will be next time, I hope it'll be next time, I'll try to have your test ready for you. Even if we don't finish 8.6, I'll go on and give it to you if I have it ready, and hopefully I will. And therefore, you can start working on it. You have an extra day to work on it, because I always give you at least a week to turn it in. This will give you a week and a half. All right. Any questions? Actually, it'll give you 2 weeks, I think, because next Monday is Labor Day, so we don't meet at all then. Bad news, but reality. Any questions? All right, then, if there are no questions, I'm going to stop sharing. I'm sick and tired of sharing, so I'm going to shut this down, and unless someone comes up with a question right away, I'm going to end the meeting. Any last thoughts? Yep, people are leaving, so I'll go on and end it. Bye-bye. See you Wednesday.